Welcome to the series of videos on C programming language. In this video, we will study higher dimension arrays. So what is the plan? First, we will look at some basic concept of higher dimensional arrays, then basic syntax, then declaration and initialization, followed by indexing, then character arrays and their properties, and a few working programs. So what is a two-dimensional array? A two-dimensional array is nothing but a single dimensional, one-dimensional array of one-dimensional arrays. Similarly, a three-dimensional array is a one-dimensional array, 1D array of 2D arrays. Likewise, n minus d array is a 1D array of n minus 1D arrays. Okay, so two-dimensional array is one-dimensional array of one-dimensional arrays. Three-dimensional array is a one-dimensional array of two-dimensional arrays, and similarly n minus d array, n-dimensional array, is a one-dimensional array of n minus one-dimensional arrays. Okay, so syntax for two-dimensional array is just like a data type, any legal data type, then legal name for an array, then size 1, that is how many rows will be there, you can say, and size 0, it means how many columns, you can say. So how many elements will be there in each row. Okay, so this is one way of declaring an array. And at this point of time, values assigned to various elements would be arbitrary. The second method is some data type, again name, size 1 and size 2. So it is a two-dimensional array, so you have to give sizes of both the dimensions. And here we can initialize. So at the time of declaration, we can initialize. So within this pair of opening and closing braces, we can have pair of braces representing rows. So list of values separated by comma, comma, list of values separated by comma, and so on. So how many such list of values will be there? It will be equal to this size 1. So we can say these are the rows. So integer value written here must be same as number of times this list of values has been written, like this. Okay. And how many elements in each of the list of values would be? It will be equal to this size 0. Next one can be another way of declaring and initializing is data type, some legal name, then size 1, size 0, and within single pair of braces you provide the number of values separated by comma. How many of those values must be there? Size 1 multiplied by size 0. So it will automatically assign values accordingly. The next way is data type, name, and here I can skip the left dimension. I can skip. Okay, need not to write anything, but this is essential, this size 0, and you can keep on writing list of values enclosed within pair of braces as many as you like. So it will deduce automatically by looking at these list of values, how many of them are there. It will deduce that what should be the value of this dimension, second dimension from the right hand side. And next final method of declaring and initializing the values is data type, name, and again you can skip. You need not to write a value here, but opening and closing brackets are essential. Then size 0, and within single pair of braces you provide as many values as you require, but the number of values must be equal to size 0 multiplied by some integer. So if you provide a wrong number of values, it will depend on the compiler. It may assume 0 or it may provide arbitrary value. So now suppose we wish to represent the following 2D array of integers in C. Now this is the two-dimensional, you can say, matrix or array as far as C is concerned. So how many rows are there? 4 rows. So we can name them as rows 0, 1, 2, 3. It will be indexing values. So how many rows? 4. How many columns? Columns are 3. So columns can be indexed as 0, 1 and 2. So in C, how what we can write is int, suppose the name of the array is capital A. So 4, 3 equal to, and then these values. So all these values, 10 comes here, 20, 30 and so on, one after the other. So C is row major. It means in the memory, the values will be stored row wise. First row would be stored first, so that is 10, 20, 30. So they will go as 10, 20, 30, then 40, 50, 60 and so on. Okay, so how many rows are there? 4. So row 0, 1, 2, 3 and each row has 3 values. So this can be done right like this. So see again, this is column 0 of row 0. So here this is row 0, as I said earlier. This is row 1 and this is row 2. So in the memory, row wise their arrangement would be like this. So for a user it appears to be a 2-dimension like this, okay, but inside computer memory they will be stored one after the other. Okay, so if I want to access, suppose you can say 80, value 80, suppose I want to access 80. So how would I reach? I will have to skip 2 rows. So this row I have to skip and this row I have to skip. It means 2 rows. Okay, so how to reach to 80? It will be A 2. Here I will write 2 and here I will write 1. So 2 rows and 0, 0 and then 1. Okay, so rows are arranged like this in linear memory. Now let us take an example of a 3-dimensional array. So suppose the name of the array is capital A, and here I have skipped the leftmost dimension. So number of rows would be 2 and in each row there will be 2 columns. So 4. So every plane, let us call the third dimension a plane. So how many elements are written here? 12 elements. So it means there will be third dimension value would be 3 here. Okay, so here we'll index it as plane equal to 0. So row 0, row 1, column 0, column 1. So you can see here it is a 2-dimensional array. Okay, so first element of a 2-dimensional array is this plane equal to 0. The next element is also a 2-dimensional array. Okay, so its index in 1 dimension is plane equal to 1. Okay, the third one is this one. Okay, so since C is row major, so all rows will be stored first. So it will be arranged row wise, but here now it will be arranged plane wise. So leftmost dimension first. So all these values, so first a 2-dimensional array will be stored first, but it is row major. So this row would be stored first. You can see here, it comes here. Okay, followed by its next row. So next row comes here. Similarly, let me clean it. Plane equal to 1. So this goes next. Okay, like this. So it's first row, then followed by second row. So here second row comes here. And similarly, the last plane. So in the linear memory, first element will be the first element in linear memory will be nothing but the plane number 0, row number 0 and column number 0. So here it is visible, you can see first plane is plane number 0, its row number 0, the row number 1, and inside each row column 0, column 1 and so on. So this will appear in memory. A 3-dimensional array will appear in memory like this. Now let us see some working programs. So in the first program, I have made a few 2-dimensional arrays. So in this line on the right pane, you can see I have declared an array named A of type integer. How many rows? 4. How many columns? 3. So how many elements will be there? or must be there 12. But here I have just declared, I have not initialized any value, so it is implementation dependent. What will be the values assigned to each element? So we'll see. You just print. Now you can see here is the left one is the row indexing variable I. What will be its value? Minimum value will be 0 and maximum value will be 1 less than the value written here, which is 4. So less than 4. So 4 rows, 0, index will be 0, 1, 2 and 3. Similarly, how many columns? 3 columns. What will be their index values? Minimum will be 0 and maximum will be 1 less than the number of columns. So it means j would be less than 3. It means what values will be there for j? 0, 1 and 2. So this nested for loop will print all the values, 12 values of array A. Next, I have declared a two-dimensional array of size 4 rows, 3 columns again, but this is the another way of initialization at the time of declaration. So you can see here 4 rows in 4 pairs of braces and 12 values. So these values must, number of items must match. Okay, and similarly this nested for loop will print those values. So here we have initialized each and every value. Nothing is arbitrary or random or left uninitialized. So this nested for loop and nested for loops are supposed to print all these values accordingly. Next one, I have declared a two-dimensional array with the leftmost dimension undefined so far. So 3 columns, and how many values are there? 12 values. So 12 divided by 3, it means it will also have 4 rows. Here also we have initialized each value properly. So this nested for loop will also be printing those values. And here I have declared and initialized a two-dimensional values or two-dimensional array with how many values? Again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 values. So it will automatically take the 12th value as sub-random value. Okay. Now here let me scroll it up a bit. I have declared here a 3-dimensional array. So leftmost dimension has not been declared or rather defined, you can say. So 2 rows each, 2 columns in each row. How many values are there? 12. So each plane has 4 values. So how many planes will be there? Planes will be, how many planes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 planes will be there. So plane index for this will be minimum value will be 0, maximum value will be 2. I have not written the nested for loop. Here you have to write 3 for loops inside one another. So for 2-dimensional, 2 loops inside one another, and for 3-dimensional you have to have 3 loops. Okay. So here I have explained to you how indexing works. Now you can see here it will not print all the values because I have not written a corresponding nested for loops. Indexing function is how to reach to a value. Now suppose I is the indexing variable for plane, leftmost dimension. Okay. J is the indexing variable for second dimension from left. Okay. So it is J. And k is the indexing variable for the rightmost dimension. So what are the possible values of I? I can take on value 0, 1 and 2 because there are the size of the third dimension from the right hand side or leftmost dimension is 3. So 0, 1, 2. How many rows are there? 2. So row will be indexed as 0 and 1. So value of j, minimum value of j would be 0 and maximum value of j would be 1. Similarly for columns, that is the indexing variable k, minimum value will be 0 and maximum value will be 1. So if I want to print the value of 1 1 1, it means E 1 1 1, plane number 1, that is second plane, row number 1, that is second row in the plane number 1, and column number 1 means here row number 1, plane number 1, row number 1, and column number 1. So in the linear memory, how far is it from the beginning? So 2 star 2. This tells you how many elements to skip. It means plane index, that is the value of I, multiplied by size of plane. It means multiplication of all previous dimensions, these two. Okay. So it is 4. 2 multiplied by 2, 4, multiplied by the plane index, which is 1. So 2 multiplied by 2, which will be 4 multiplied by 1, plus, now go to the next dimension from the left hand side. So indexing variable is j, its value here is 1, so put 1 here, and multiplication of all other dimensions on the right hand side. So on of j, there is on the right hand side there is only k, and its size is 2. So 2 star 1, then plus 1, it means value of k. So this comes out to be 7. So in linear memory, index number 7 in linear memory, if we consider this as a single dimension array. So this is 0, this is 1, this is 2, 3, 4, 5, 6, 7. So it will print 80. Okay. Now you can see here, pay attention, you can see here I have written E015. 0 is within the range, 0 1 2. 1 is within the range because there are 2 rows, 0 and 1, but here column exceeds. Column goes beyond 2, so people think that it will be printing a random value or arbitrary value because it has gone beyond the highest possible indexing variable as far as rightmost dimension is concerned. It will not happen. Substitute these values in the above formula in this particular case. So this will be 0 multiplied by 4, which is 0, 1 multiplied by 2, which is 2, plus 5, 7. Again it will print 80. Okay. In the next example, E115, so 1 multiplied by 4 here, plus 1 multiplied by 2 is 4, plus 2, 4 plus 2 is 6, and 5 11. So what should it print? 0 1 2 3 4 5 6 7 8 9 10 11. It should print 120. But here I am sure if we substitute these values, so 1 multiplied by 4, 4, plus 2 multiplied by 3, which is 6, plus 4, which is already 10, and plus 5, 15. It goes beyond this. So highest index here is 11, which is based on 0 indexing. Indexes start from 0, so 0 through 11, 12 elements. This is 15. This is, of course, out of range. So it will print some arbitrary value. Okay, so let me execute the program. Now you can see here, okay, first one was, you can see, first one is this one. So it has printed all these values, random values. Okay, so it depends on the implementation. If I rerun it, okay, if I rerun it, then it may print something else. May or may not, I don't know. Rerun it. Now you can see here, it has printed almost the same thing. Sometimes it prints the same thing, same values, sometimes it prints some different values. Nothing can be, we cannot be sure about it. But now, corresponding to this second array B, it has printed all those values which we have initialized. In the third array C, again it has printed the same values. Okay. Now the next one, array D. Array D, Let me clear it. Yeah, array D, we have initialized 11 values, 12th value we have not initialized. So now you can see here it has printed 0. Okay, so even if we rerun it, it is printing 0. We cannot be sure that what will be the 12th value. Now come to array E. Now you can see here, first printf, it has printed 80. Okay, next printf, again it has printed 80. Okay, third one, 11, indexing function will yield a value 11, which is the last element 120. It has printed the value 120. But here, since it has gone beyond the range, total number of elements is 12. It has resulted in a number 15. Since it is a single dimensional array, in that sense, in the linear memory, it will print some arbitrary value. So you can see here it has printed some arbitrary value. If we rerun the program, it was, you can see the value has changed. So in higher dimensional arrays also, a 2-dimensional, 3-dimensional, 4-dimensional, any dimension, any number of dimensions, if you initialize each value, results are guaranteed. If you do not initialize particular value, what value will be assumed? Nothing is guaranteed. It depends on the implementation. In this program, I have declared few character arrays, single dimension as well as 2-dimension, and tried to print strings and characters based on rows and columns. So here in the first statement, I have declared a character array str1 of size 4, but not initialize any values. I have not assigned any values to any element. So this statement should print arbitrary value. Okay, so let me execute the program. Yeah, so here printf, it has assumed that there is nothing. It means it has initialized all elements to null character. Okay, it has printed one space. Next one, next is I have declared without providing the size str2 another character array and initialize 4 elements, capital A, B, C, D. So actually internally it will store 4 values and it will reserve 1 byte for null character, that is \0. But for user, the size of array is 4. Okay, last character is null character. Corresponding to this, if I print, it will print A, B, C, D, because what happens is it starts printing from the first character position. I have asked this to print it as string. So just name of the array, it will start printing from the first location, and it will continue until it encounters null character. So A, B, C, D it has printed. The next one is a 2-dimensional character array in which leftmost dimension has not been defined. So I have declared or I have assigned 4 strings, character strings or character array. So A, B, C, D is first row, E, F, G is second row, third is H, I, J, and fourth is K, L, M. Now we know that the size of each row has to be same. So internally what will it do is it will pad with some value which is normally a null character. Okay, so here A, B, C, D, for us it will be occupying 4 values. Here it will be occupying 4 values, 4 values and 4 values. Now here I want to print as a character str300. It means dimension row number 0, you can say this, and character number 0, it means this. So it should print lowercase letter A. Now you can see here it has printed lowercase letter A. Next line str31, it means second string I want to print. Okay, and I have asked it to print it as a string. So it will start from E, F and G, and it will stop there. So you can see here it has printed E, F, G and it has stopped. So let me clear it. Now next one is %C, that is character. str3 0. It means here, but 5. So how will it count? 0, 1, 2, 3, 4 is E, 5 is F. So it has to print F. Now you can see here it has printed F. But here I am asking it to print as character string str3 3 5. So it is 0, 1, 2, 3, but 5, that is 0, K is at 0, L is at 1, M is at 2, 3, 4, 5. It means it is beyond the range. It is beyond the range, so it can print anything. So it has printed here some space character. Next time when we run, it may again print a space character, or it may print some arbitrary character. We don't know. We'll see it a little while from now. Now here I have asked it to print as a string str3. It means start from here and keep on printing. So A, B, C, D. Then it will print E also, F also, G also. But since it has 3 characters only and it has to have 4, so 4th character internally it has stored as null character. So it stops there only. So now you can see here A, B, C, D, E, F, G. It is printed. Now the next example, it is a 2-dimensional array. It means 12 elements. So I have assigned 12 characters. Interestingly, I have assigned intentionally 1\0 to demonstrate something. As string, I want to print str4 0. So str4 is the name of the array. 0 means start from here. Okay. Now you can see from here it will start printing and it will keep on printing because I have asked it to print it as string. So W, X, Y, Z, 1, 2, 3, 4, capital A. Then this one is null character. As soon as it is encountered, printing stops. So it will print W, X, Y, Z, 1, 2, 3, 4, capital A. That's it. So we can check. Now you can see this one up to and including capital A. So in the memory it encountered null character, so it stops printing. Now next one is str4 0. So it means this one. From here str4 0, here str4 2. Okay, what I want to print it as string. So how many characters are there? 4 characters in each row. So 0, 4 characters, 1, 1, 2, 3, 4 and 2. It means the row number, third row or third string will start from capital A. It starts printing from here, but immediately next character is null character, so it will print only capital A. So you can see here it has printed capital A. Okay. Now the last one is %C str4 2 2. So 2 4 characters, then again 4 characters. Not 2 is this, so 0 0 is this, 1 is this, I mean this 2. So it will print only capital C because I have asked it to print single character. So it has printed capital C. Now let us test this statement. Okay, it is supposed to print arbitrary character, which was printed here. Okay, so let me do this and rerun this. Now you can see here again it has printed after F space. Now because I have tested number of times, now you can see here this is this, it has printed D. Okay, let me rerun it. Now in that place it has printed space. Now again capital T. Now again space, space, right brace, closing brace. Okay, so what does it mean? It means just like integer array or floating point array, if some value has not been initialized, it depends on the implementation what character or what value would be assumed in case of character arrays as well. In the next video, we will study structures, struct and union. That is all in this video. Thanks for watching.